Yes, sir.
Yes, sir.
Okay. Good morning to all of you. Let's
Good
start
morning,
with
sir.
our next topic of the unit fifth, uh, which is we have started, uh, and already the number of points we have discussed. So our today's point in case of the robotics is mobile robot hardware, and in that topic we will study about the architecture or the structure of the mobile robot as well as the various kind of hardware components, and based on the hardware component how the subsystem can be described related with the mobile robot. Okay, so as already we know, the mobile robot uh, is replicating the human behavior, and in that way we are making the robot. So just like the human being has to navigate the environment when he goes to the some new location, so in the mind of or in the brain of the human being also, he need to build the maps, he need to make the plan, and accordingly he need to proceed. Okay, in the similar way, the mobile robot also need to do the navigate, also need to navigate their environment in whichever environment the robot is present, and also he need to build the and update its maps. So map, okay, so whenever configuration of the robot get changed automatically, the robot's maps also get changed. Okay, accordingly, and accordingly the planning get done, and the robot perform or execute the actions. Okay, so just like the human being is very flexible to the environment, if a human being goes from the one environment to the other environment, accordingly human being get adapt with that kind of environment. Okay, so same kind of flexibility is also available with the robot. Same kind of flexibility is being instilled in the robot when the robot is being made, so that the robot can work together with the other robots also, and robot can work together with the human being also when robot goes from one particular environment to the another environment. And accordingly the robot also has to learn the new thing from their experience, previous historical data. Okay, so to do all these kind of things which is replicating the human being, and there is a necessity of high computing power. So computation need to be done fastly, so that only the robot can take the required action and perform the activity. And for that, as you can see, in case of the human being, there is a natural components are available in case of the human being, and that is the reason human being is having the certain kind of computing power. Human being can think accordingly, imagine the things. But in case of the robot, such kind of things are not present naturally. It has to be inbuilt, it has to be uh, uh, it has to be instilled into the robot with the help of the some kind of hardware and the software architecture. So we have to utilize some hardware and the softwares in case of the robot, so that he can perform these kind of things or activity just like the human being. Okay, so and it is possible to make the such kind of robot which can easily work in the changeable environment, and which can easily make adapt to themselves to the change in the environment, and sense the environment with the help of the various kind of sensor which are used to be there in case of the robot. Okay, so the environment is never used to be the constant. It always used to be the dynamic environment, always used to be the change from one particular situation to the other situation, and whatever things are available in the environment, that things has to be sensed by the robot. Okay, and to sense these different kind of things. Okay, just like the human beings are having the ears, nose, etc. So these kind of things we can put in, we can put these kind of things into the robot with the help of the sensor. Okay, so in case of the robot, there is utilization of sensor uh, to what we can say, to sense the different kind of things or the parameters from the environment. Okay, but what can happen, only one sensor for certain activity is not considered as a sufficient. Okay, so using only one sensor, it might not be possible that robot will sense the all the kind of things from the environment. Okay, so there can be utilization of more than one sensors related with some single activity in case of the robot. Okay, and using that more than one sensor, data is being collected, and this data collected from more than one sensor is being combined together, which is considered as a sensor data fusion. Okay, so instead of sensing the data using the only one sensor, it will be more practical to have more than one sensor, and when the data is get collected from the more than one sensor, that data is get combined, and that particular thing is considered as a sensor data fusion. So if the data is collected from more than one sensor, then the particular probability of correct action is also get increased. Okay, so as we know, the different kind of sensors are having the high bandwidth. Okay, and even if we see any powerful sensors, there always used to be the inevitable processing latency. So what do you mean by the processing latency? What is the meaning of processing latency? Yes, you must have come across this word latency number of times. What do you mean by the processing latency? Hmm? Yes. Have you heard this word before? Yes or no?
सो लेट होणं म्हणजे
Delay. Okay.
डिले.
Correct.
हा
Delay. So किती जरी पॉवरफुल सेन्सर्स असले तरी डिले can always be there. So if the data capturing delay is there, then definitely processing happens when data is get captured, and then only the processing happens on that data. Okay, so if the delay happens in the capturing the data, then definitely the subsequent operation also get delayed, and so there always used to be the some kind of processing delay. Okay, so because of which the control the way we can control the robot, the we can that control cannot be 100% what we can say correct, or we cannot control the robot 100% accurately because of such kind of processing latency, or we can say we cannot get the 100% kind of output from the robot because of such kind of processing latency. But what we expect practically from robot, that it should operate in the real time. Okay, but if the processing latency is there, then is it possible to operate the robot in the real time? I hope you are getting the meaning of real time. Yes, if the processing latency is there, then is it possible to it is can we expect the operation from the robot in the real time?
नो.
No. So real time in the sense, as soon as you get the data, the processing should happen at that instant only, without any fraction of delays. Understood? But delay always used to be there. Okay. Inevitable means what? We cannot avoid such kind of fraction of delay. That is the meaning of inevitable. Okay. Now, in order to achieve these different kind of things, and to get the output from the robot, the strong hardware need to be there in case of the robots. Okay, and kind of architecture design also need to be selected accordingly. Okay, and the robot always used to be the process large amount of sensory data in order to build, or to take the action according to the data it received from the environment. Okay, so because of that, we need to select the kind of control architecture which will support these processing tasks in the timely manner. Okay, and that is the reason we used to, or the those who are designing the architecture of the robot, so they used to select the kind of architecture because of which the minimum delay can be occurred. Okay, the flow of information from sensing to the action should be maximized, and minimum delay can be occur. So in order to achieve this kind of things, that information should get processed fastly, flow of information should reach to the uh, processing component of the robot fastly. If suppose, if the flow of information to the processing component of robot need to be passed fastly, then sensing has to be done fastly. Okay, because that in case of the dynamically change environment, that there is always used to be the changes in the data very fastly and very frequently. So control architecture need to be selected accordingly, so that speedily information can be passed, and minimum delay can be there when we expect some response from the robot. Okay, and accordingly, the most popular kind of mobile robot architecture being selected based on the distributed concept. So here I have mentioned, so for mobile robot, distributed processing architecture is the one of the good choice. Okay, distributed processing architecture, which offers number of advantage for coping with the various complex computation processing, and for performing the quick action. Advantage for coping with, in the sense, coping, meaning of the coping means when you are dealing with the different, meaning of the coping in the sense, deals with something. So when we have to perform different kind of when the robot has to perform different kind of complex things processing, and has to perform the quick action. So from the lot of experiment, it is being find out that the distributed processing architecture is considered to be the good choice. Okay, as compared with the other kind of architecture. And accordingly, there are the two different design principles are being utilized in case of the designing the architecture of the mobile robot. And one of that is the, which is most popular, that is the functional decomposition. Okay, functional decomposition design principle is being utilized. Now, what exactly is this functional decomposition? So it is being considered as a classical top-down approach to build the robot system. Okay, so what exactly mean by the top down? Why it is being referred as a top down? Now it is just like divide and the conquer way. Okay, divide and the conquer way, in the sense, the entire control task of the mobile robot is divided into the number of subtasks are, and then these subtasks are implemented by the various separate modules. So that's why I'm calling it is like the divide and the conquer way. Okay, I hope you are getting the meaning of divide and the conquer, where we divide the where we divide the complex task into number of subtasks, and then we solve it. So same thing. So this architecture, this design principle related with the architecture of the mobile robot, it is based on the same thing. That is the reason it is being referred as a classical top-down approach to build the system. So where what is happening, the entire control task of the mobile robot is divided into the multiple subtasks, and then in order to in order to carry out these multiple subtasks, or in order to carry out these or complete these subtasks, there is a utilization of different kind of separate modules and separate components in case of the robots. Okay, so that what are that separate modules, what are that separate components, that in the subsequent next part we are going to see. Okay, so these separate modules can also be referred as the functional modules. So these functional modules form a chain, and through which the information flows from the environment to the robot. Okay, so how the information flows from environment to the robot? With the help of the sensors, and again back to the environment via some actuators. So when the information flows from the environment to the robot, then with the help of the some of the components of the robot, the processing of that information happens, and after processing, robot has to take the action. So when the robot take the action, that action is get performed where? that action is get performed in the environment. That is the reason here I have mentioned this functional modules forms a chain through which the information flows from environment to the robot. Now, in order to information to flow from environment to the robot, there is a utilization of different kinds of sensors. And when these information get processed by the processing component of the robots, then again, with the help of that, with the help of the result of that processing, action is performed by the robot within a environment with the help of the different kind of actuators. So in this way, this closing feedback loop is from environment to the robot, again robot to the environment. Okay. So this scenario always continue when the robot is performing his activity in the environment. Okay. So to do so how these functional what exactly are these functional modules are, and what are the functions of each of these functional modules, how these functional modules are interrelated to each other, these different things we are going to see in this particular part. So this is nothing but the general. I hope all of you can able to see this figure. Yes.
Yes, sir.
Yes, sir.
So this is the general architecture, or you can call it as a structure of the mobile robot. Okay, which also quietly look like the robot only. Okay, in that way it is being drawn, where you can see the different functional modules are shown there, and each of the functional modules are being quietly interconnected with each other. So you can see here, this is the vision head, then this is the laser scanner, this is the LICA controller, LAP, these are the sonar rings, this is the resolver component, motors, wheels, okay, encoder, motors, VC board, etc., etc. Okay. So these things, this with the point I am telling you, ki functional decomposition principle is utilized for the architecture of the robot. मग त्या functional decomposition मध्ये which functional modules are there? So these functional modules are there. So within this each functional module, the particular what we can say, whatever task has to be performed by the robot, that task is divided into these different sub modules. So automatically, that when the task is get divided into the different sub modules, that task become the subtask. Okay. So what we have to see now, what exactly these different functional module do. Okay. And how the robot work by using these different kind of components. Okay. So in that, firstly, we have this on this topic. Most of the time question asked on the explain the mobile robot hardware or the structure of the mobile robot. So this diagram is very important, and the kind of textbook you refer in textbook, there is only diagram is given, no explanation of such kind of component is given. So you can afterwards you can write down this what exactly these components are for utilized. Okay. Now let's see, we'll discuss one by one about each of these component. So firstly, we have the LICA controller. This is the LICA controller. Okay. So its long form is the local intelligent control agent. What? Local intelligent control agents. Okay. So it is here I mentioned, it's functionally it is very simple. It is just like the brain of the robot. Now what the brain of the human being does, now whatever processing is happen, it's happen with the help of our brain. Okay. Now it consists of the various number of processors. You know, the if the processing has to be done, always there is a utilization of the processor. So this LICA controller consists of multiple number of processors. Okay. So it is used to collect the information from various input devices such as the sensors, sonar rings. What exactly these sonar rings? Okay, we will discuss. But you can just see, you can see these to this LICA controller, different other components are attached, and that is the reason here I have mentioned it used to collect the information from various input devices such as the sensors, sonar rings, etc., etc. And then it execute the program. Okay, and in according to that, it control the various other output devices like motors, light, actuators, etc., etc. So after it receive the information, it does the processing of that information, and after processing of that information, it performs some action, and that action is performed with the help of the different output devices like motors, light, actuators, etc., etc. So we can say it. Can we call it as a sensor interpreter? Yes. Can we call the LIC controller as a sensor interpreter?
Yes, sir.
Because it is interpreting the whatever the information it receive from the different kind of sensor. So also we can consider it as an interface for the external sensor and motors, etc., etc. So this is the main component. This is the main component of what we can say structure of the robot. Okay, or architecture of the robot, where it does the where its function is what it accept the information, process the information, and according to that the action is being performed by the other output devices. So this is the first component. Understood this one?
Yes, sir.
Then next we have the motor. Here you can see now motor. What for what purpose motor is utilized? Yes. Along with the
Moving.
motor moving movement, to do the any
Why?
kind of movement, there is a utilization of motors. So along with the motor, there is a utilization of another component, that is the actuator also, which is not shown here. But if they have shown just the motor, it is okay. So motor, here I have mentioned, it is used to actuate something in your robot. Actuate something means it make the robot to perform some kind of activity. Okay. So it is used to actuate the wheels. Actuate the wheels म्हणजे काय? It is responsible for the movement of the wheels, tracks, arms, legs, and weapons also. If the robots, can we attach the weapons to the robot? Yes.
Yes,
Yes,
sir.
we can also attach the weapons to the robots. Understood. So movement of that weapons, for all these things, the motor is there.
Yes.
Okay. And what kind of now motor? There are the different kinds of motors are there. AC motors are there, DC motors are there, etc., etc. But special kind of servo DC motors are utilized. Direct current motors are utilized in the robots to ensure the correct positioning and the movement. Okay, keep in mind, in the most of the robots, servo DC motors are being utilized. This point will be helpful for you. Okay, for your general knowledge also. What kind of motors are being utilized in the robot? Servo DC motors are being utilized. Okay, so this is the second functional module or the component we can see. Then next we have the sonar ring. Okay, it's sonar ring. It stands for the sound navigation and the ranging. In the physics, you must have heard about this device. Okay, sonar ring device, which stands for sound navigation and the ranging. Okay, so it is a kind of a technical device which being utilized uh, as a sound propagation. Okay, which uses the sound propagation. Now, particularly, these devices are being utilized for the ships. Jahazaमध्ये this kind of devices are being utilized. Okay, where with the help of the sound propagation, with the help of the sound underwater, with the help of the sound propagation, navigation and the communication can be done. Okay. Also, with the help of the sound propagation, the detection of the object, if whether the object is on the surface of the water or object is within the water, that object can be detected with the help of these sonar ring devices. Okay. So these kind of devices can also be utilized in the robot. Okay, for the purpose of what? Detection of the object. Sound propagation means what? Okay, sound propagation. So if there is some particular object is there, okay, with the help of the sound propagation, with the help of the sound propagation, some rays are being released, and when they if there is some object is there somewhere in the water or in the environment, that sound get okay, that sound get stuck with this object, and then automatically if this sound gets stuck with this object, automatically from that it can be concluded that there is some obstacle is there, some object is there. Okay, so there are multiple number of such kind of sonar devices are connected to the LICA controller. You can see here, these are all the sonar rings which are being connected to the LICA controller. So its sonar ring job is what? With the help of the sound release or with the help of the sound propagation, it helps for the navigation to find the direction, or it helps for the communication purpose, and for the purpose of the detection of the any obstacle is there on the way of robot, or any obstacle there in the way of the uh, sheep. Okay, so for that, for in case of our robot, main activity is being performed with the help of the sonar ring is also the same, navigation and detection of the object. Okay, so this sonar ring can also be utilized in the robots if we have the robots which is being utilized on the surface of water, or if you have the robot which will be utilized under the water also, then these kind of devices are being utilized. Okay, understood the sonar ring.
Yes, sir.
Then fourth one, we have the laser scanner that you can see here. Okay, on the LICA controller, the laser scanner is attached. So you know the laser scanner is being it has the capability to penetrate through the physical things also. So it can penetrate through the walls also. Penetration means what? Yes, what do you mean by the penetration?
Sir, R पर
Okay, so
जी
it can go out of some physical devices. Okay, it can
yes
okay, so that is the meaning of the penetrate. So these devices you can see here is attached on the LICA controller. So main utilization of this laser scanner is to take the distance measurement. What? For the purpose of distance measurement from all the direction. Now it is help to the robot to determine where exactly robot is present. Yes or no? For the positioning of the robot. To know the जे questions आपण काल बघितले, how the robot will know where actually he is present. So to know that all these kind of things, these different functional modules are utilized. I hope you are getting correct or not.
yes sir
So in order to measure the distances from different direction, there is utilization of this laser scanner. So this kind of scanner can rapidly capture the surface shape of the object, any kind of object, building, landscape, whatever kind of object is there, it is able to capture the shape of that objects also, and it can able to measure the distance also. So with the help of this laser scanner, we can get the exact size and the shape of the objects. Also, we can get the distance measurement from the different direction for the robots. Okay, so this is the fourth one, that is the laser scanner. Then next we have the vision head. Okay, you can see here vision head is there. It is just like the camera. So it is for the visual guidance of the robot. For what purpose? For the visual guidance of the robot. So it uses the camera as a vision head. Okay, बरोबर ना, robot ला, you know, for the, just like we are having our eyes. Okay, so for that to perform the functionality of the eyes, it is having the vision head. Okay, so for this is being utilized for the visual guidance of the robot, and it uses the camera for that, and it gives the capability to the robot to visually perceive the environment and use this information for the execution of the different kind of tasks. So its utilization is mainly for the robot navigation as well as for the obstacle avoidance. So vision head is mostly important for the purpose of the navigation purpose as well as for the purpose of obstacle avoidance purpose also. Okay, so this you can see this is being also attached to the other components which are being there. Okay, so this is the vision head. Then next we have the robot encoder. Okay, robot encoder. So you can see here robot encoder is there. Okay, and you can see it is being attached to the motors, and again motors is being attached to the wheels. Okay, so here I mentioned these are sensors which are attached to the rotating objects such as wheels, motors. So what for what purpose this is being required? So this is being utilized for the purpose of measurement of the rotations. Okay, for what purpose? Measurement of the rotations. Now, by measuring the rotation, what for what purpose the rotation need to be the measure? Yes, from that what can be what conclusion can be made by measuring the rotations of the motors or the wheels, etc., etc. Yes, with the help of the measuring the rotations of the wheels, motors, what conclusion can be made by the robot? Hmm? So by measuring the rotation, can it help us for the measuring the speed, that is the acceleration? Yes or no? Can the speed
Yes, sir.
determination? Yes,
Yes,
speed
sir.
determination can be done by measuring the rotations of these wheels, motors, etc. So same thing I have mentioned here, by measuring the rotations, robot can do the things such as determining the displacement, velocity, acceleration, angle of the rotation, etc., etc. So for that purpose, there is a robot encoder is there. You can see. Okay, so this is the sixth component in case of the structure of the robot, that is the robot encoder. Then next we have the resolver. You can see the resolver here. Okay, so resolver, it is like a electromagnetic device, okay, which convert the mechanical motion into the electrical signal. Okay, and so resolver is the type of the rotatory electrical transformer which is used for the measuring the degree of the rotations, at which degree the rotations are happening. So this actually helps to the robot encoder also, resolver. So resolver functionality is what? To convert the mechanical motion into the electrical signals, and to measure the degree of the rotation. What is the degree of the rotation? So that is nothing but the functionality of the resolver component that you can see here. Okay. Then next we have the LEP that you can see here, which stands for the lateral effect photodiode. Okay, lateral effect. Now this kind of devices usually utilized in the docks. Docks means what? Yes.
दोहरा
Hmm?
धागा
No,
दोहरा
no. Docks is another word for the ship. Jahaz. Docks is another word for the ship. So in the ship, this kind of devices generally utilized. Now for what purpose? It is for the purpose of detecting the close objects. Means the object which are very close to the ship, which can be also considered as an obstacle also. So for the purpose of detecting the close objects which is very near to the ship and which is making the movements, So for the purpose of detection of that kind of object, there is a utilization of these lateral effect photodiode devices. So here I have mentioned this kind of devices generally utilizing the docks for the close object or obstacle detection to avoid the any kind of collision. Collision in the sense, yes, collision means what? Collision,
धडक
धडक,
टक्कर
टक्कर. तर काय आता आपण इथं बघितलं की सोनारिंग हे बरेच अदर डिव्हाइसेस आर ऑल्सो यूज फॉर द ऑब्स्टॅकल डिटेक्शन, बट समटाइम्स इट
Yes.
माइट हॅपन की longer distance object might be get detected with the help of the sonar rings and other kind of what you can say the laser scanner, etc. But it might happen some close objects which are or obstacle which are very close to the ship. It might not be possible to detect with the help of such other devices where this kind of LEP, lateral effect photodiodes, are being utilized. So just like it is being utilized in the docks or the ships, so this kind of devices can also be utilized in the robot also. Okay, for the purpose of close range object detection, which are very close to the robots. Okay, which might not be get detected by the other devices. So that close range object can be detected with the help of the lateral effect photodiode kind of devices. Okay, so with the help of this all the kind of what we can say the components, the this our particular robot structure forms, and accordingly the robot perform the different kind of activity. Okay, now from these all the you can see the combination of various hardwares like physical components that we have seen. Okay, so we can say the mobile robot is the combination of various kind of hardware physical devices plus software computational components. The software computational components we have not seen up till. Okay, that in the further section we have, but we have seen these are the different kind of what are the different kind of hardware physical devices are there. Okay, so in terms of the hardware components, now we on the basis of these all the hardware components that just we have discussed regarding the mobile robot, we can divide that structure of the mobile robot into the four subsystems. Okay, on the basis of hardware components we have discussed, we can divide the robot structure into the these four subsystems. Okay, means what we are trying to divide the uh, activity performed by the robots. Okay, as a group, as a what we can say as a subsystem. Okay, so on the basis of hardware components, we have these four subsystem related with the mobile robot. Okay, in that first subsystem we have, that is the locomotion. What do you mean by the
Yes, sir.
ओके, सो जे आपण हार्डवेअर कंपोनंट्स डिस्कस केले, तर ऑन द बेसिस ऑफ दॅट द मोबाईल रोबोट is considered as a collection of some subsystems, and which are that subsystems are these. Okay, in that first one you can see locomotion. So locomotion means what? So this subsystem is related with what?
Movements.
Movement. So here I have mentioned locomotion subsystem specify how the robot moves through its environment. So for the purpose of locomotion, we have seen the other number of components like it utilize the motors, wheels, etc., etc. Okay, so these things comes under this subsystem as a locomotion. Then sensing. Sensing is nothing but what? Measuring the parameters from the environment. Yes or no? Sensing in
Yes,
the
sir.
measuring the properties of the environment. So here I mentioned it mainly shows the robot measure the properties of itself and its environment. So for that purpose, there are the different kind of sensors are being utilized. In the next part, we are going to see which are the different kind of sensors are being utilized. Okay. So that is the another subsystem, sensing. Okay. Then we have the reasoning. So reasoning specify how the robot map the measurement into the action. So in the measuring, we have the component LICA controller. Yes or no? What the LICA controller does? LICA controller receive the information, process that information, and accordingly the action is get performed by the other components. So that is the reason here I have mentioned reasoning is what reasoning subsystem of the robot is what it specify how the robot map the measurement into the action. Mapping the measurement into the action means what? What do you mean by this? Mapping the measurement into the action. Yes. Hmm. Mapping the measurements into the action.
सेन्सर्सनी जो डेटा म्हणजे पॅरामीटर्स घेतले त्याच्यावर त्याची ऍक्शन डिपेंड आहे.
Correct. G information, the information which is received through the different kind of sensors and other devices, with the help of that information, the action, which action to be chosen, that is being specified by the this reasoning subsystem. You know, there is utilization of LICA controller for that. So that is the reason here I mentioned it specify how the robot map. So meaning is the, how the robot convert that measurements into the action. Meaning of the measurement received information. And last subsystem we have that is communication. It specify how the robot communicates with an outside operators. So for the robot to communicate with the outside operator, now can be the user considered as outside operator? Yes or no?
Yes, sir.
So how the robot can communicate with the outside operator? Then there is utilization of remote control, there is utilization of text interface, etc., etc. I hope you must have seen the robot demonstration with the help of the remote control. Yes. With the help of the remote control, we can control the robot. बघितलं नाही असं तुम्ही कधी?
Yes.
Okay, if not, you can see this kind of videos on the YouTube. Okay, so that is the with the help of these different kind of things, the communication with the robots can be done, or the robot can be communicate with the outside operators. Okay, text interface I said. Text interface म्हणजे काय की जर तुमच्या रूम मध्ये रोबोट्स असेल and it is being connected with the computer system, so with the help of the keyboard also you can give the instruction to the robot. Yes or no?
Yes, sir.
So that is the communication subsystem. Okay, so these are the different things related with the mobile robot hardware and the structure of the mobile robot. Okay, and subsystem related with the components of the mobile robots. Okay, so this is the 10 to 12 question 12 marks questions can be asked on these topics, where the different where 4 marks question can be also asked on the mobile robot subsystem. Okay, and 10 marks can be asked on the structure of the mobile robot with this diagram, etc. Correct? So that's it from the today's session. Remaining will continue in the next part. Okay.
Okay, sir.
Okay, thank you all of you.
Thank you, sir.